So in this lesson today, we're going to be on page 273 if you've got your workbook. Go ahead and pause the video and get that out. If you don't, and open up page 273, we are going to be continuing our understanding of ratio concepts. So we're going to be able to describe what ratios are and also how to compare two quantities to one another today. So on page 273, we have our first problem here, and this says Carlos makes baked pears for his little brother. Complete the model to show the ratio relationship for the ingredients in the recipe. Over here on the right hand side, you can see that recipe for baked pears. It says for every 4 pears there are 2 cups of yogurt and 6 tablespoons of granola, and it would like you to complete this model over here to represent that recipe. As you can see, it already tells you that the pears are represented by these circles. So we have 4 pears, but it only has 1 square for yogurt. And so we need to represent that by doing 2 cups of yogurt. So we're just going to add to our model another cup of yogurt by adding a square. At this point, you could probably already see what we're going to be doing with these triangles. Tablespoons of granola, the model is only showing 1 tablespoon, and so we need to show 6 tablespoons according to the recipe. So we are just going to add 5 more triangles to represent all 6 tablespoons. So now we have 4 pears, 2 cups of yogurt, and 6 tablespoons of granola. And that's a way we can model a ratio with ingredients. Number 2 is using the same recipe here. It says there are 4 pears for every 2 cups of yogurt, right? Because it takes 4 pears for every 2 cups of yogurt. The way that we can write that as a ratio is by doing 4:2, and the way that we read that would be 4:2. But if I just said the recipe has a 4:2 ratio, you might not know what I'm talking about. So another thing we need to add is a context. We are talking about pears, 2 cups of yogurt. So the pears comes first and the yogurt comes second in our ratio. What I'd like you to do is try to write these ratios in those 2 different ways for A, B, and C. So go ahead and pause your video and do so now. All right, so for part A, the ratio of cups of yogurt, which was 2, to pears would be 2 to 4, or another way to write that would be 2:4. The ratio of cups of yogurt in part B here, the cups of yogurt to tablespoons of granola would be cups of yogurt, which is 2, to the granola is 6. Or the way that we say it is actually 2 to 6. Lastly, the ratio of tablespoons of granola to the cups of yogurt, well, we know tablespoons of granola is 6, and the yogurt is 2 cups. Or we can read that as 6 to 2. Number 3 here, we're going to be using that same model in problem 1 to complete these sentences. So the ratio of blank to blank is 4 to 6. Well, what is 4 to 6? Well, we've got 4 pears to 6 tablespoons of granola. So that's going to be pears to tablespoons of granola. Whoa. I'm going to abbreviate that. And then because there are 4 pears to 6 tablespoons of granola. The ratio of blank to blank is 6 to 4. Well, what is 6 to 4 then? Well, that would be granola to pears, right? Because how many? 6 of what? 6 of what? 6 tablespoons of granola for every 4 pears. So the order in which we do these ratios is actually kind of important, right? But context is also important. A 4 to 6 ratio is not necessarily the same thing as a 6 to 4 ratio, but in this case, they're representing the same things. There's 4 pears for every 6 tablespoons of granola, but there's also 6 tablespoons of granola for every 4 pears. In this case, those ratios are kind of the same. Number 4, go ahead and pause the video and try this one out on your own. Okay, so Salem records the types of ducks he sees on a nature walk in Central Park in New York City. It says to draw a model. That's important. We're not just going to write the ratios, but draw a model as well to show the ratio of mallards to ruddy ducks that he finds. We can see here that we have 8 mallard and 5 ruddies. So we need something to represent mallard ducks. You could use letters or shapes. I'm going to go ahead and use M's for mallards. I need 8 of those because that's what my data over here is telling me. So there's 8 of my mallards, and then my data also tells me there were 5 ruddy ducks. I'm going to use capital R for that. Again, you can use squares or circles or stars to represent these as well. But now we have an 8 to 5 ratio, or a 5 to 8 ratio, depending on what we're talking about. Moving on with the same example, it says that we can talk here, let's just read it. Some ratio relationships involve parts to larger whole. For these relationships, ratios can compare 2 parts or a part and a whole. So for instance, in both of these cases, mallards and ruddies are both ducks. We could look at this and say, hey, how many ducks are there in total? Well, there are 13 ducks total. So I might actually use a ratio of mallard ducks to total ducks. Well, and that's kind of what part A is talking about here, right? What does the ratio 8 to 13 represent? Well, the ratio of 8 represents our mallards to our total ducks. Okay, this is a part to whole comparison, right? It says circle the type of ratio it is. Well, that would be a part to whole, just like we said. So that's a part to whole, because mallards is only part of it, and the ducks is the total amount of ducks we're talking about in our data. Number 6, it says Carlos uses 2 cups of yogurt and 6 tablespoons of granola for every 4 pairs. Would it make sense to describe this situation with a part to whole ratio? And explain. So go ahead and take a second and think about whether or not that's okay to use a part to whole ratio to represent that. Remember, in our very beginning, we had 2 cups of yogurt for every 4 pairs and 6 tablespoons of granola. Okay. Does it make sense to talk about a part to whole comparison or ratio with these ingredients? Now you may have said yes and had a good explanation for it. I personally would say no. Why? Well, I'm not going to write this all out, but the thing is like when we're talking about mallard ducks, right? If we're talking about mallard ducks versus ruddy ducks, in both cases, we're talking about ducks. That makes sense to do a part to whole comparison if necessary. But in this case, I don't know if we can make that comparison, because if I add this all up, 4 plus 2 is 6 plus 6 is 12. I have 12 what? Ingredients? Maybe. In this case, it actually might make sense to do a part to whole. In this case, it would be 6 tablespoons of granola for every 4 pairs, and then also 2 cups. Would it make sense to do a part to whole? Is that 4 to every 12? There's 4 pairs for every 12 ingredients? Well, 12 what ingredients? How are you measuring the ingredients? It's not cup of pears, cup of yogurt, and cups of granola, right? So now we have to talk more so about what are we talking about with our ingredients? Are we talking about cups of ingredients? Tablespoons? Just pears, the number of fruit? So this doesn't make sense because we can't necessarily group all of our ingredients into one type of measurement. So I would say no because of that. If I had ingredients that were all cups, then maybe we could do that. All right, all this says is an exit ticket. I also have some practice for you afterward. But the exit ticket here says the puppies in a litter are either black or brown. The ratio of black puppies to the total number of puppies is 3 to 8. So what does that mean? Well, that could mean a couple of things. Let's change up our colors here. What is the ratio of brown puppies to black puppies? Well, hold on. We have black to total, right? So black to total is 3 black to a total of 8. But now it's asking for brown to black. So what I need to come up is from brown to black ratio, right? Well, how many black bears were there? Well, there were 3. So let's just put a 3 here for the black puppies. For the brown puppies, how many brown puppies were there? If there are 8 total puppies and 3 of them are black puppies, how many of them would be brown? Well, that would mean that there would have to be 5 brown puppies. If we only have brown and black puppies, 5 plus 3 would give me a total of 8 puppies. So my brown to black ratio would be 5 to 3 brown puppies to black puppies. To draw a model that supports this, we have, again, black puppies. Well, let's do black. Black puppies will represent those with circles, and then brown will represent those with squares. I know for a fact that I have 3 black puppies. 1, 2, 3. And I have a total of 8. So I have 3 puppies so far, so I need 1, 2, 3, 4, 5. That makes a total of 8 puppies. So that means I have 3 black puppies and 1, 2, 3, 4, 5 brown puppies. So brown to black would be 5 to 3. All right, go ahead and look over this example. You can see here that the student in the drama club are either actors or crew members. That's it, actors or crew members. And for every 6 actors in the club, there are 4 crew members. What is the ratio of actors to students? So all the actors and all the crew members are students. So what it's saying here that there are 10 students total. So if we want to do actors to students, that would be a 6 to 10 ratio, or the way to write it is 6:10. So what is the ratio of crew members to actors? Well, go back to that. How many crew members are there? 4. Right? And we're doing, again, crew to actors. How many actors are there? There are 6. So this is going to be 4 to 6. It says to write it in 2 different ways. Use the word 2 and a colon. So there's the word 2. So now we can also write this as 4:6. And that'd be crew to actors. In your answer to problem 1A, why is the order of numbers important? Well, the order of numbers is important because I don't know what 4 represents and the 6 represents. This is why it's so important to have a context about what we're talking about. The order of 6 to 4, if I said 6 to 4, for every 6 crew members, there are 4 actors? No. For every 6 actors, there are 4 crew members. So we need to make sure that that order stays in place so that we know that for every 4 crew members, there are 6 actors, right? So that tells me that there are going to be more actors than there are crew members. If I flipped it around, all of a sudden I have more crew members than I have actors. All right, number 2, you could probably try this one on your own. It says last season, the ratio of number of soccer games won to the number of soccer games lost was 3 to 2. Very important here, none of the games were tied. So representing a model, I'm going to use letters in this case, because you can. We'll say that the number of 1, 2, the number of lost was 3 to 2. So we won 3. So a win, and a win. And then losses were 2. So L. Here's a model that can represent that. And then in part B, it does say tell what each ratio represents in this situation. 2 to 3. Well, that would be 2 losses to 3 wins. What about 3 to 5? Well, I have 3 wins, so that's got to be 3 wins. 2, well, I've got 5 total games played because remember, none of the games tied. So we got 3 wins to 5 total games. Remember what we talked about these, right? We called this a part-to-part comparison. And we called the second one a part-to-whole comparison. All right, let's go ahead and try this one out. Again, as always, pause the video and try it out on your own. It says Paloma rides a scooter and she travels 10 feet for every 1 second. You can kind of see that modeled here. It goes 10 feet, that took 1 second. Another 10 feet will take another second, that's 2 seconds. And again, so on and so forth. Hannah says that Paloma's ratio of seconds traveled to feet traveled is 10 to 1. Is this correct? Well, hold on a second. It's 10 feet to 1 second, or it's going to be 1 second to 10 feet. Paloma is saying the ratio of seconds to feet. Okay, well then it should be a 1 second to 10 feet. But this is backwards. And it says use a model to help your thinking. If you think about this for 1 second, or let's do feet. So we got 10 feet, 2, 3. We got 10 feet traveled every 1 second. Now she is comparing seconds to feet, and she's saying that should be 10 to 1, which means we should have 10 seconds for every 1 foot. So she's actually got that backwards. If she wants to do seconds to feet, then she needs a 1 to 10 ratio. Gaspar also rides a scooter. He travels 2 feet farther for every 1 second than Paloma. So if he's traveling not 10 feet, but 2 more than that, which is a 12 feet to 1 second. Right? What is Gaspar's ratio of feet traveled? 2 seconds, right? And he's traveling 2 feet more than Paloma's. All right. Describe a real-world ratio in which this model could represent. We've got some type of 5 to 1 ratio, or maybe a 1 to 5 ratio, or maybe a 5 to 6 if you're doing a part to whole, or a 1 to 6 ratio. This could be anything, right? Mr. Nelson eats 5 cookies for every 1 minute, right? It could be a number of things, so you can come up with that. Or maybe you go with, I eat 1 cookie every 5 minutes. It just depends on how you're talking about these ratios. Come up with something that's described there. Number 5 there, we'll call this our exit ticket. Go ahead and try this on your own. You've got 4 cans of orange, 7 cans of green, and 8 cans of purple. What would 8 to 19 represent in this situation? Go ahead and try that on your own. It's not too bad. You got 8 cans of purple and 19 what? And you got 19 total cans of paint, right? So that is a part to whole comparison, and that calls that one good. Do an explanation though in your workbook, and that is it on just some basics, foundations of ratios.